Welcome to The Explainer. Today, we're diving deep into an organism that's really started to move from the sidelines right into the clinical spotlight, Moraxella Atlantae. This bacterium story is just a perfect example of how modern technology is completely reshaping our understanding of opportunistic pathogens. Okay, so here's our plan. We'll start by figuring out what this organism really is, then get into diagnostics, clinical impact, and the critical challenges it presents for treatment and public health. Oh, and a quick note on our sources. This whole analysis was put together using a Gemini deep search. If you want to dig into the primary literature yourself, you can access the full list of sources in the linked notebook document. All right, first up, what exactly is Moraxella Atlantae? So, while it's often been thought of as just a low-virulence bug, the evidence is becoming crystal clear. When you find Moraxella Atlantae in a sterile site, we're talking blood, you name it, it is a critical, clinically significant finding, period. And its journey is really fascinating. It went from this obscure reference lab curiosity, literally just CDC group M3, to a pathogen we can actually diagnose. And that path, it perfectly mirrors the evolution of the clinical microlab itself. Okay, so let's head over to the lab bench because a huge part of this organism's story is just how darn hard it used to be to identify. On a plate, it gives you some pretty helpful clues. The big one, the really distinctive feature, is its ability to actually pit the agar surface. I mean, it literally corrodes it. That, plus being oxidized and catarrhalis positive, that'll get you a pretty strong presumptive ID. And right here, this is the heart of the problem and the solution. Its biochemical inertness, it basically made it a ghost for older systems like API strips. It just wouldn't react. But now we have multi-TOF MS and 16S sequencing. These modern tools unmask it with ease, giving us rapid, confident IDs. So now that we can actually find it reliably, what does Moraxella Atlantae actually do to people? Now, what's really striking here, even with just a few cases, is the pattern. It is absolutely consistent. We're seeing severe disease, sepsis, and even sight-threatening keratitis. And what's the common thread? Every single time, it's a patient with significant underlying health issues. This just hammers home its role as a true opportunist. Okay, this leads us to a huge challenge. You've identified this in your lab, now what? How do you advise the clinical team on treatment? Well, here's the problem. There's basically a vacuum of information. If you look at the Dutch swab guidelines, for example, you'll find no specific recommendations for Moraxella Atlantae. And it's not just a local thing. The situation is exactly the same internationally. Major players like IDSA and ESCMID, they're totally silent on this bug. So this leaves the clinical lab in a really tough spot. What's the right procedure? How are you supposed to report susceptibilities when there are no official breakpoints to hang your hat on? Well, the key here, the absolutely crucial point, is to follow the formal EUCAST guidance to the letter. You run your AST and you report the quantitative MIC value, but, and this is the big but, you do not assign an SI or R interpretation. Instead, you add that standardized comment and advise a consult with an infectious disease specialist. That's the protocol. And it is so important not to get this mixed up with its very common cousin, Moraxella catarrhalis. Why? Because their resistance profiles are polar opposites. More than 90% of Moraxella catarrhalis is beta-lactamase positive, resistant to amoxicillin. Moraxella Atlantae, on the other hand, no beta-lactamase reported. So treatment has to be guided by those AST results, which makes that initial ID absolutely critical. All right, let's pivot to what might be the most important piece of this entire puzzle, the future threat of antimicrobial resistance. So on paper, Moraxella Atlantae looks fine. You test it, and it seems susceptible to our last resort antibiotic, colistin. No red flags, right? Wrong. The real danger is hiding in its genes. We now think the entire Moraxella genus is a likely evolutionary origin of the plasmid-mediated colistin resistance genes, the MCR genes. These are the very genes that are now threatening the usefulness of colistin worldwide. This has huge One Health implications. It connects the dots between human, animal, and environmental health. It basically elevates the whole genus from a minor pathogen to a silent reservoir for resistance genes, a reservoir that could spill over into a major human pathogen at any time. Okay, last but not least, let's talk practicalities, prevention, control, and lab safety. In the lab, the rules are crystal clear. This is a risk group 2 pathogen, so all work has to be done under strict BSL-2 conditions. That means using a Class 2 biological safety cabinet, proper PPE, the whole 9 yards. And this leaves us with a final, really interesting thought. With our diagnostics getting so much better, are we finally seeing the true incidence of Moraxella atlantae? Or are we just seeing the tip of the iceberg? That's the big question. So that's our look at Moraxella atlantae. If you found this useful, definitely subscribe for more explainers like this. And hey, if you have any clinical experience with this bug, please share it in the comments below. Let's help each other build up our collective knowledge. Thanks for watching.